Good morning, everyone. I hope you guys are doing well. Today, what we're going to do is finish up 16.2, and we're going to talk about thermodynamics today. This section is going to start at 482, and let's just jump into what thermodynamics is. It is the study of conversions between thermal energy and other forms of energy. So who gets credit kind of for this is going to be James Joule. He gets credit for discovering the first law of thermodynamics, which involves work, heat, and energy. And what I want you to do is look at how his experiment said that thermodynamics is around. So it talks about that his experiment involved a falling weight, a paddle wheel, and a container of water. And what he did as the weight fell, it would go onto the paddle and it would turn the paddle, and then some water would drop. Well, the water heated up due to the friction from turning the paddle. He measured the work done by the falling weight, and he found that the work done by the weight was almost exactly the amount of thermal energy gained by the water. So it's showing that basically the work on the machine was then turned into thermal energy, which talks about the thermodynamics of the first law. So let's jump into the first law, and then we can go back to his experiment and see how exactly it showed that the first law was correct. So the first law of thermodynamics, remember that we talked about the law of conservation of energy, that energy cannot be created or destroyed, but it can be converted into other forms. So the first law states that energy is conserved. Well, we talked about his experiment, the rock falling, going onto the paddle wheel, and dropping water. Well, the force being done, so the work being done by the rock, right, caused friction. And that friction turned into thermal energy. So the work being done by the rock was almost exactly the same as the thermal energy gained by the water. So it states that sorry, I didn't mean to change that. It just shows how energy is conserved. Yes, it was transferred into a different form of energy, but it was still conserved. It wasn't created or destroyed. They used this example out of the book, which is a bicycle pump, and they said that the system is the tire, the pump, and the air inside the system. So the force exerted on the pump is useful, and some is transferred to thermal energy. Well, if you think about it, when we are pushing down on the pump, right, we're doing work on the pump. Some of that work is going to go into the tire and be useful and pump up the tire, and then some of the work is going to be lost due to friction. And friction, we can see that that's causing thermal energy because it's heating up. So that's an example of how it's created or how it's not created or destroyed. It just forms into a different form of energy. And here's a perfect table that just goes over the conservation of energy, and that's energy loss equals energy gain. Calories lost equals calorie gained. Work loss equals work gain. So these are just a couple of examples of what the first law of thermodynamics is. And we can see how that goes back and relates to James Joule, is because the work being done by the fallen rock was almost exactly the same as the thermal energy gained by the water. So all it did was change into different forms. So it wasn't destroyed, it just went into a different kind of energy. second law of thermodynamics is the second law of thermodynamics states that thermal energy can flow from colder objects to hotter objects only if work is done on the system. Well, in the book, they talk about pulling out a glass of water from the refrigerator and you let it sit there, and is that water going to get colder? Well, no, silly. If you think about it, you let your juice out or you let your water out for a little bit, it's going to warm up. Well, we know that thermal energy travels from hot to cold. But if work is being done on this system, it can flow from colder to hotter objects. Example of this would be the refrigerator. So work must be done to transfer thermal energy from the cold food compartment to the warm room. If you notice, there's coils on the bottom of your refrigerator or on the back side of your refrigerator, and they release thermal energy. They're releasing heat basically into the refrigerator. Well, it uses a heat engine to convert the heat into work. So the thermal energy given off by these coils use a heat engine to convert this heat into work. The thermal energy not converted into work is wasted heat. So basically it's not used. But remember that you have to think that this machine, it has friction, so it's going to be, some of the work is not going to be used. That's going to be wasteful. But remember, machines can never be 100% efficiency because of friction. So some is lost, which would be your waste heat. So work is being done on the refrigerator, so thermal energy can flow from cold to hot. It's pushing that air out into the warm air outside of the refrigerator. So that thermal energy is going from, because thermal energy is heat. You don't want that in the refrigerator, so it's going to pump it out into the warm air of the refrigerator. I mean, the warm air outside the refrigerator. Then our last law that we're going to talk about is the third law of thermodynamics. And all I want you to know is that the third law of thermodynamics states that absolute zero cannot be reached. Sorry, I kind of stuttered that out. So once again, the third law of thermodynamics states that absolute zero cannot be reached. It has not been reached. There are very close into labs, but it has not been reached. So that is all I want you to know about the third law. So first law, we can look at the pump, the tire, and us doing work on it. That's an example of the first law. Remember, first law is just basically the law of conservation of energy, saying that energy cannot be created or destroyed. Second law is saying that thermal energy can flow from cold to hot as long as work is being done on the machine. And then the third law is just stating that states that absolute zero cannot be reached. I want you to know those three laws, and I want you to be able to give me an example of the first two laws. So that is all we have to go over today. What I want you to do now, and I already wrote this in RunWeb just in case you get to this video and you stop it right away. The assignment for today is going to go to page 483, and you are going to answer the questions 1 through 10. All right? Watch this video, answer your questions, and that will be the end of today. Tomorrow, do not forget, we have a 9 o'clock Zoom session just going over questions that you might have for the week, and then you will have a vocab quiz on Monday. Also, we are not going to be going over 16.3. We are going to be skipping that, so I will be giving you a study guide on Monday, and your quest, or I'm considering a test, is going to be on Wednesday. Alrighty, I hope you have a great day. See you guys.